The search for exoplanets capable of supporting life is one of the main objectives of the James Webb Space Telescope, and one day we may be able to look for evidence of this. However, because habitability is not a simple concept, finding another planet with characteristics similar to Earth may be trickier than you think. Hello my people, before we start with the episode today, make sure you are subscribed to our channel and drop a like. In this video, we'll discuss the James Webb Telescope discovery that we'll make on ProximaB, where a spectacular star system can be found discovered about 40 light years away. NASA made headlines around the world 5 years ago when it revealed that it and several other partners had discovered a slew of Earth-sized planets orbiting within the habitable zone of a single star. Since that time, people have been eager to learn more about these nearby worlds that may be similar to our own planet. Enter the James Webb Space Telescope, which during the initial phase of its operation provided information about these nearby worlds that may be similar to our own planet. There may be many challenges to overcome when attempting to understand universes that are not similar to our own recent modeling work. Indicates that the distance a planet eye from its star depends on its size. The aim of the research will be determined whether or not any of the planets in the TRAPPIST-1 system have atmospheres. In the long term, the goal will be to devise a method for searching for biosignatures that could indicate the presence of life on any of the planets. A planet's potential habitability is also significantly influenced by how much land is present on its surface. What is new? Mrs. Evelyn MacDonald, on Monday, July 11th, a doctoral student from the University of Toronto in Canada, presented the results of recent research on exoplanets. The researchers based their simulations on the nearby exoplanet Proxima Centauri b, which is roughly the same size as Earth. Red dwarf stars like TRAPPIST-1, Proxima Centauri can be found in our own neighborhood because there are these stars that are significantly smaller than the Sun. Proxima Centauri b is tidally locked like the other planets in the TRAPPIST-1 system, so that planets can orbit much closer to them while still being in the star's habitable zone. Despite the fact that none of the planets in our solar system have anything somewhat similar, this means that there is always a side of the planet that is facing the star and a side of the planet that is facing out into space. It is not uncommon to see this behavior in exoplanets. There was a time when people believed Mercury was tidally dependent, but the situation turned out to be quite different. The dark side has always turned its back on us, as astronomers anticipate that one side of the planet will be significantly hotter than the other tidal exoplanets, which could impact habitability. On the other hand, this problem could be mitigated if the atmosphere had winds that spread heat evenly around the planet, making it a place where life could thrive. Away from the star is known as the night side. The MacDonald-led team studied how the amount of land on a planet's day side affects the planet's temperature. In her presentation, MacDonald said we changed the amount of land on the globe while keeping it in these configurations, making the circle of land larger or smaller. This improved our understanding of the impact on the climate that this would have. They compared a scenario in which land was located in the middle of a liquid ocean on a circular continent with another scenario in which land was located in the middle of a circular ice cap. The model predicted that there would be less precipitation, warmer temperatures, and a wider temperature difference between a plane's day and night side. There was an increase in rain and clouds when there was a higher percentage of land on a planet and when there were more oceans. The researchers found that the distribution of that land could cause the average surface temperature of a tidally locked planet to vary by as much as 20 degrees Celsius. This was the case even when the total amount of land remained the same. The amount of ocean water that was liquid at any given time had an effect on the total amount of water in the atmosphere, as well as the temperature of the globe, because frozen ocean water may occur at any time. It is difficult to react because no one has really seen this distant planet that circles around a red dwarf star in the Goldilocks zone because it has a fairly substantial climate variation just caused by changing the quantity of land and where it is located. Scientists have simply discovered that Proxima b, which is around 4.2 light years away from Earth and is precisely where it should be since Proxima b is tidally locked to its star, is exactly where it should be by observing the frequent tiny variations in Proxima Centauri's hue. Red dwarf stars are not as hot as yellow dwarf stars like our Sun, so Proxima b might contain water and its atmosphere might shield it from the Sun's rays and disperse heat to the planet's dark side. However, only one side of it is ever illuminated and is always facing Proxima Centauri. It orbits its star with barely an 11.2-year revolution. Using NASA's James Webb Space Telescope, the JWST, in 2018 as a one-way astronomer Laura Kreinberg and Harvard's Ava Loeb think, we can be certain. The long-delayed JWST is anticipated to debut in 2011. Loeb theorized that if a rocky planet like Proxima b had an atmosphere, it would absorb light from its star and re-emit it as infrared radiation. The JWST was built specifically to examine infrared light. The JWST can take infrared images of Proxima b's surface to check for patterns that would indicate whether or not this exoplanet has water or an atmosphere, but things aren't that simple. The recommended approach might be practical, but there are other factors to take into account as well. However, the only possibility we have for a glimmer or an explanation regarding this Earth next door is Loeb and Kreisberg's idea. For example, according to Princeton University astronomer Ed Turner, the intense heat of Proxima b might be like Venus, and the presence of an atmosphere may not be a guarantee of life with an atmosphere 90 times thicker than ours. The James Webb Space Telescope will map the atmospheres of exoplanets. Exoplanets, often known as planets outside our solar system, have been found to circle stars other than the Sun. The planets in our solar system are visible to the unaided eye as brilliant dots. For example, Proxima Centauri b, the closest exoplanet to us, is 4.2 light-years away from us, or 206,000 times farther than it is from the Sun. When viewed through a telescope, the huge red spot on Jupiter, Saturn's rings, or the Martian ice caps can all be observed. These kinds of phenomena are predicted to exist on exoplanets, but since they are so far from the Earth, we are unable to resolve their surfaces directly. However, there are methods to fully more comprehend and map their atmospheres. James Webb Space Telescope has a number of objectives. One of the most crucial is to look for exoplanets that could support life and where we might someday be able to look for signs of it. However, habitability is not an easy concept to grasp, and finding another planet that is Earth-like may prove to be more complicated than you think. With this, we end our video. Thank you for watching. Ask us if you have any questions in the comment box and let us know your views.